Good morning, everyone. So
Morning.
my name is Nicolas. I'm the head of information management from NUWARD.
And I'm Teck Khiew. I am also in the information management team. I'm the deputy of the team.
So we've got, I think, 25 minutes of presentation following by Q&A. What we are going to talk today about is about data-driven strategy and surveying performance. So I will start by asking a question, but I need first you to think about your own organization. And imagine that in your organization, in your project, I'm sure that you come across that question many, many times. And you try to answer a question like this one. If a requirement is changed after you have significantly progressed, what would be the impact on the design, on the procurement, on the construction, contract, cost, and schedule? And I'm sure that if you think about your own organization, the answer might not be straightforward. So why this is getting an answer so hard to get today? The first thing that you have to think about in a project, all along the life cycle, you've got multiple silos. You've got the engineering, you've got the project management, the procurement, the construction. We could have also the commissioning. So that by themselves are silos. And now if you look at the process that are inside each of these silos, you will have many solutions that try to manage this process. And all these solutions also contributes to create additional silos. Now, if you try to get the data from this to be able to answer your question, you will have to face a lot of multiple format, Excel, Word, PDF, to be extract the information from all these solutions. And if you really look now about the question and the fact that you want to get relation between them, you will start to see that there is a lack of data continuity. And even sometimes you don't even have the data. So all this exercise to try to answer a simple question is very time and resource consuming. You need to read documents, interrogate system, KPI, dashboard, talk to people, have a meeting to discuss about the data, the quality of them, email, whatever. So after a couple of days later, you might have an answer, but at the same time, you will have a lot of other questions that will be raised during this process. Now, what if you could get this answer in just a few seconds?
So what we are proposing here is a different way of looking at your data. So we call it the knowledge management rather than just data management. So maybe the next. So we in NUWARD, we come up with a strategy that we want to be 100% data-centric from day one. So we are not just pushing documents around between different stakeholders. We want to make sure that all our data from the beginning are 100% usable by all the systems, and they are made available to people that needs to use it to make decisions. And to support that, the only way we could do this is to join up all the data from different silos. And the way to do that is through connecting the data points from different data sets through a graph. A graph basically is a relationship between different data objects. You can think about there's a subject predicate object means that you have objects related to different objects. We will talk a bit more about what it means. But these objects carry the data that some of it will be text-based, some of it will be numbers, some of it will be simply just explanations of things. And we want to be tool agnostic, which means that it doesn't matter which tool you use to produce the data. What's important is to be able to extract data and combine them with other data sets to form a full context for answering any questions that you may have. And starting at the bottom, I'm sure you probably have seen this pyramid before. What we have in this day and age, we digitalize our process, we digitalize a lot of our solutions, and we produce a huge amount of data. And this data needs to put in the context to form meaningful informations that can then be used by people to make decisions. And what more important is that all these informations that you gather from different sources have to be combined in the context of what is your data model, how things are related to each other. I'm sorry, it's a bit abstract right now, but we will explain a bit more how we approach this problem. So ultimately, what you want is that all the data is fully linked, doesn't matter which silo it comes from, and we can use this data, a single data platform, to answer any questions from engineering all the way down to the end of the life cycles.
Okay. There is also a very important element, in addition to what Teck just said, is the ontology. So the first thing I want to do is to really apologize if we've got any ontologists in the room, or philosophers as they call themselves. It's a very, very, very simplified view of what is ontology. So why an ontology? So as you have been able to see that there's a lot of data that come from different models, from different domains. So we need to have a shared vocabulary and also the definition of the constraint, the relation with the different object. So this is why you've got what we call class, requirement, a function, a system, a component, work package, activity. All these different classes come from the different domain. And you will start to establish also the relations that are defining basically what exists between, as Teck said, between a subject and an object, the predicate. So it allocates, it decomposes, it satisfies, it depends on consume, affect, cost. So when you have this vocabulary and when you have also the definition of this relation, this is where you can start to unify. You unify domains through these relations. So for those who are familiar with system engineering, for example, the product breakdown structure, the functional breakdown structure, the geographical breakdown structure, and the requirement. But you can after also go into another domain, schedule, cost, risk, and contract. One of the things that also give you the ontology, which is really very powerful, that is used in many other industry, is what we call the reasoning, and the reasoning and impact propagation. So I'm going to give you a very simple example. It's called what we call the inference. So basically, you've got an object that has a certain property. Let's say I'm going to take something when you have an animal that is nursing its young. By just knowing that it's nursing its young, you know that it belongs to a class, the mammal class. So this is something which is really important because it's not a simple data model that just defines the relation between objects. It also gives you an ability through the reasoning to be able to, and the propagation of the property in all your ontology, to be able to access to information that will be very, very difficult without it.
So let me give you an example. So this is an example of an ontology for a knowledge graph. You can think about ontology, it's sometimes referred to as your data model or your structure of your database or how you relate each other in traditionally, you probably do this in a relational database where you have stored data in tables and then you try to join different tables. But what we're doing here is that we store data in a graph form. And a graph looks something like this. This is a simplistic view of a graph. On the left-hand side, you can see that there's a lot of design information related to your product. And the right-hand sides are project information related to schedule, cost, anything to do with your contracts. And what we do here is that we establish all the relationship between different classes of information. So if you think about all these different circles contain data, and it can be many circles. In a graph, you can go up to millions data points, and they're all related to each other through a defined relationship defined in your ontology. So different color here represent data coming from different silos. So for example, at the beginning of your project, you may define a set of requirements in one tool that you use. It doesn't matter what tool it is. And then that requirement translate into defining your product breakdown structures, the functions, how the system and structures deliver these requirements. And you then go and do your design. Your design further decompose system into individual components. These components are equipments, your pipes, your tanks, your reactor. All this carry data, and you can go and buy something through a contract. Someone's going to make the equipment for you. Someone's going to supply you the material. They provide data as well. And some of this data is in the form of documents. You can also link documents to different data objects. And in your project management side, you're going to have your schedule, your costs, and all these are linked together through a defined relationship. So how does this work when you want to answer a question that we posed earlier? So taking, for example, I start from requirements. So requirements changing. What would be the impact on cost, for example? So your start point is a requirement, and your end point is a cost with the yellow circle there. So through the graph, you can establish the path. It's a bit like your maps service. You have the start and end point. You can establish any path between the 2 points. And you can then interrogate the graph and extract. This requirement change will lead to maybe there's change in the cost of material, or it may be related to an activity in your project that will have a significant impact on the schedule or your procurement. So by connecting the data, now you suddenly have access to the entire knowledge of your project. And you can do this for any type of impact assessment, whether it's cost, schedule, or your design changes.
Okay, so now you have seen you have seen the graph. There is one thing that we are going now to talk about, which is we try to leverage the technology. So, and basically what we're trying to do here is that you are going to use generative AI. So one of the things which is really think about your graph, all the knowledge, your project, all your data, the relation, the property are in this graph. And you could basically have people that will connect to the graph, and through queries, Sparkle, Cypher, will be able to interrogate this graph for you and be able to get the data. And here, where it comes with the generative AI. Basically, the generative AI will allow you to ask the question in a natural language. So, and the AI also understands the structure of your graph, the ontology. So it has the ability to transfer your natural language into a query that will interrogate the graph and retrieve the data from the graph. So when after it will have retrieved the data from the graph, it will also add an additional layer of, it could also prepare based on the structure of the information, I would say a structured answer about the question that you have asked at the first time. So what is the interest of this? It's, if you look at when we talk about generative AI, there is a lot of companies that are using what we call the RAG approach, unstructured data. One of the issues with this approach is that the LLM has a tendency to hallucinate. So what it does is that basically it will pick up some words and it will establish relations that might not exist. And it will give you something which basically is not reliable. With this approach, what you do is that you've got a way to really interrogate the graph that has all the information, and through the query, you've got something which is really relevant because the relation are the right one. The graph is not, the LLM is not going to invent any additional type of relation. So it will retrieve exactly the data that are relevant to your question. And it's a way to really be able to limit the hallucination of the AI. Oh.
So let me just again give you an example that. So let's ask a question. So we are just making some fictitious question and answer here. So imagine you have a chatbot that is made available to all the managers or decision makers in your projects. These kind of questions can then be asked, which without taking a lot of time. For example, if I change the number of this requirement, what will be the impact on the design, construction, contract, cost, blah, blah, blah. And the first thing that the AI will do is that the AI is informed by your ontology. Basically, the ontology ring-fence the AI to tell the AI that these are the data structure and these are the predefined relationship between these data sets. And you can use this ontology to then inform how you build the query to retrieve the data from the database, from the graph database. So the next step will be the AI will then take the ontology, understand it, and then know that there are these objects and they are the defined classifications, and build a query that will go to your graph and go and retrieve the data. And what you get is that it will then identify all the circles, like what I shown earlier. It will identify all the nodes that contain all the key data that will be relevant to your questions and all the values of different properties associated with those data points. And it can then even go further that if you wish, you can build that kind of analysis tool in your AI that can help you to take this data in context and provide you a summary of what the data is telling you. And perhaps it can also help you to analyze what is the likelihood of an impact to affect any subject or any endpoint that you're interested in. So don't pay too much attention to the numbers here. These are just big numbers that just to illustrate the power of the AI that can help you to make decisions.
Okay, so going back to the question that was asked at the beginning, and as currently in most of our organization, we spend a lot of time really to try to get access to the data. And we are not spending any time, not enough time, I would say, on really where is the value added, is the analysis of them, and defining really the best scenario or the best option for our business. So one of the things that we were trying to show you is that the first thing that is really important in all this presentation is that most of the, I would say, the value added is really on defining, really building this knowledge graph. This knowledge graph is very key. It will automatically, it will get the information of all your authoring tool, and basically you will have them in this knowledge graph, which is completely agnostic, and that is a representation of the complexity of your project. So when you have this, and when you have to pay attention to define properly, again, not only the data model, but also the ontology associated with it, you will have something which is very powerful and that really unify all your data model all along the life cycle of your project. So, and on the top of this, we've got the generative AI. And the generative AI basically is something that just acts as a kind of translator that avoid you to have to learn anything about Cypher or whatever, that will be able to take your question and query the graph for you. And on the top of this, from the answer, we'll be able to analyze really the answer, the data, and start to share this information with you to be able to really start the next step, which is the analysis of the result. And this is where you will be able really to where you really need to focus for your strategy execution and decision making. Thank you.
Thank you very much. So we'll take any questions. So don't be shy.
You want to? Okay.
Hi, thanks for that presentation. I'm just curious how this process has changed the actual NUWARD design, particularly since you went back to the drawing board a year ago and abandoned the integral design.
I think this approach, really, we are in NUWARD, we have started really from the conceptual design phase, being 100% data-centric. What this approach is allowing us at the moment is really being able to really accelerate. There's a lot of things that we could have done without it, but it's an approach that basically allows us to improve the quality of the information that we're having, but also getting much quicker information. So it's really something that allows us to go faster, rather than, I'm not going to say that at the moment it has changed the design itself. And when you look at the presentation, what we aim is the entire life cycle of the project. So at every step, it's more about being able to, every time that you have something that could be a change, an opportunity or whatever, to be able really to understand now what are your options and to get quickly an answer so you can take the decision. And this will happen all along the life cycle of the project.
And I will add to that that it's not a trigger for us to, because we do this and we revisit the design. It's more so that in NUWARD, every single piece of equipment, every single system exists in the design. There's a data behind it that can explain to you why they exist, because we can trace all the rationale behind why certain things exist. There are no things exist because it's nice to have, because we have a very competitive market that we want to keep the design what we could deliver the design to the requirements of our product and our stakeholders. So everything is explainable through the graph. We can answer any question and any relationship of the design with any other aspect of the project.
So thank you for your presentation. My question is for this kind of approach, is quality or quantity way to explain the relationship between your requirement and the project or something like that. So that's my first question. The second question is, what's your key problem when you're developing this kind of the approach in your project? So, thank you.
You want to answer for the first part?
So the quantity, quality, if I understand correctly, if you're talking about data quality and the quantity of data, or?
I mean, it's just a description answer or some kind of the quantity.
So I can't disclose to you in terms of the reliability kind of percentage accuracy. We are still working on it. We are constantly improving all the different steps. There are different ways to improve the quality of answers. One thing I would say is that this process does not replace human in the loop. You still need to have the experts to analyze and confirm that what the AI is giving you is reliable and accurate. What we do is to make sure that the AI can give you the shortcut to locate the information. You can verify as a human operator, and it accelerates the process of just simply collecting the data to answer questions. And obviously, we have to expand the use case to a lot more different domain. And also, I would say that you still will have your traditional reporting, your monitoring KPIs, we're not replacing that. What we are doing here is to try and accelerate some of these maybe out-of-standard questions that you may ask, or maybe standard monitoring tool doesn't give you the information or doesn't give you the complete set of information. So that's one thing. The other thing about the challenges that we face is obviously a big cultural change. It needs to be instilled in the people's mind that from day one that we need to think about the data. It doesn't mean that we don't have documents. We still have documents living in the, for legal reason, commercial reason. But we need to think about the data that is used to produce the document. Organize your data in a structured way, and then the document can then be produced semi-automatically. And what's important is that when the data is linked, you can then trace if something is changed, then you will know which documents was affected, and you can actions whatever you need to do to correct it. Any more questions? Well, if you can think of more questions, I will just share another bit. Is that another thing that a lot of people ask us is about what tools do we use? What solutions, what IT solutions do you use? Do you have, our approach is always, we don't want to, put ourselves in a position where we are married to a tool, where our process is driven by the tool and not the other way around. So what we want here is that our data model, the graph that you've seen, is agnostic to any source of information. Whether what we look for in a tool, when we select a tool, is the ability to extract the data that we need in a structured way. And we tend to let the people to decide what is the best tool to carry out your duty in the project. We don't mandate people to say you have to use this tool because this is the way I extract data from this tool.
Yeah.
So that is a very big cultural change for us, is to not to tie ourselves in a corner that you are limited by the ability of the tool that you select. What's important is the data. Data is the valuable asset that you use for making sure that you can carry out your project to adhere to the cost and schedule targets.
In addition to this, that if you think about the end of the life cycle of the project, as you said, Teck, the value is in your data that have been produced all along the life cycle of the project. So if you have all this residing on the existing system, the authoring tool that you have used all along this life cycle, it's first a major issue for the long term, and also for example, in case of a nuclear plant, about the transfer to the future operator. You've got a way to have this graph knowledge that basically has all the information associated with your entire life of your project, and it's a very easy way after to facilitate the transfer and the handover to the operator.
Yeah, I think we live past the age of like handing over a container size of information in documents to the owner or operator. I think we have to think more about all this digital data we produce and we leverage to build the project. How do we transfer that knowledge, the graph, to the customers, and then they can leverage the same data to optimize their operations and maintenance. And that's the aim of our goal here, is that to extend these to cover, future operations.
Any other question? Oh, okay. Okay. Okay, ça marche. Oh, okay. Okay,
Yep.
so thank you very much.
So we will hang around here for a bit. If you have any questions, you want to talk to us, please feel free to come and talk to us.
Thank you.
Thank you.